So we completed this project in collaboration with Stonehill Environmental Partners, which is an energy infrastructure company focused on the entire life cycle of fixed water pipeline, recycling, and disposal assets. As a quick overview of our project, we standardized field equipment programming with the SCADA configuration, creating a unified data model, enabling the rapid onboarding of new facilities with a fully mobile responsive, modern card-based UI, all while overall lowering costs. So let's take a deeper dive into the problem that we needed to solve. The existing assets were a mixed bag of brownfield solutions. There were multiple hardware brands, all initially programmed by different groups. These assets varied wildly in their configuration standards, making routine operations much more difficult than they really needed to be. Stonehill is also growing rapidly and has evolving business objectives. Field-wide changes were difficult to achieve, and so it became pretty obvious that more agility in field automation and SCADA was necessary to achieve their organizational vision. So, how did we go about tackling these particular issues? By first understanding Stonehill's organizational vision and the pain points they had with their existing solution, we were able to develop a new unified data model. We had two main goals during development of this particular model. The new model is flexible. It's able to grow and evolve alongside Stonehill's changing business needs. It's also scalable, maintaining organization and being easily understood regardless of how large the system may become. This work led to a comprehensive framework that enabled us to simultaneously align the brownfield solutions I mentioned previously with the new data model and standardize our field equipment configuration, automation programming, and ignition UDTs. All of this sounds great in a presentation, but how did we actually achieve it in the real world? We first needed to find the right hardware that wouldn't require us to compromise on our own vision for the system. We found that hardware solution with Opto 22. Their Groove, Epic, and Rio devices are extremely durable, surviving brutal Texas summer heat. They feature a powerful IDE in the CodeAssist platform with generous licensing and training resources. They also come with a great price, so it's pretty much a no-brainer. We've been extremely pleased with Opto 22's offering and support. And before I get this question, no, I am not affiliated with them in any way. I'm just a fan of their products. We use a cloud-based VM infrastructure for scalability and cost savings. Our server, our server architecture follows a pretty standard hub and spoke approach that you may be familiar with from previous Ignition webinars. We've fully embraced the MQTT communications paradigm and rely on Cirrus Link's Chariot MQTT broker for our communications heavy lifting. So let's take a look at what our architecture looks like. So starting from the left, we have our field devices communicating via MQTT Sparkplug B to the Chariot broker. We also have several instances of Node-RED running in Docker containers used for data simulation purposes. This allowed us early on to scale our design to over 10,000 distinct physical sites with full data load during our performance testing. We also have a redundant pair of backend gateways that are solely responsible for tag IO operations. And from there, our history is stored in a highly available, redundant PostgreSQL database cluster with primary, standby, and dedicated development nodes. We utilize a central gateway for other tasks that may require heavy processing loads, such as API functionality, data ETL scripts, and so on. This central server also houses alarm notifications via SMS, email, or good old-fashioned phone calls. We have a redundant pair of front-end gateways to handle prospective client sessions and reporting duties. From there, data is served out to clients. We utilize Okta as an external identity provider for some extra security measures, which I'll get to here in a second. So Earlier, I mentioned a unified data model. And so let's dive a little deeper into what that means. While some think of a data model as nothing more than a tag naming scheme, for us, it's comprised of much more. In our system, each piece of equipment being used in the field has an associated data package. This package, for the most part, consists of a few common elements. It's UDT, which obviously contains its tag configuration, including those naming conventions. It includes a particular view, which acts as a quick look or summarization of its data, which we call its card. Another view that shows all tags associated with that piece of equipment, called its detail view, and its associated field configuration standards and or automation code templates, depending on what we're talking about. These packages were designed from the ground up to be highly parameterized and reusable in a wide variety of situations. Adding copies of existing packages is seamless and quick, allowing us to rapidly onboard entire new facilities or add equipment to existing sites. We can even build new types of facilities by simply mixing and matching existing data packages. After all, a tank is a tank, regardless of what's inside. Perspective allowed us to deliver all of this functionality in a truly modern way that our users already instinctively understand how to use. Early in our design process, we used style guidelines published by Apple for iOS and Google for Android to design what I believe is a functional user face that looks great. I'm really proud of what we've done here. Our system is fully mobile responsive and has full feature parity between our mobile and desktop versions. You can do anything in our mobile version that you can do in our desktop version. As you saw in the architecture diagram, we use an external identity provider, Okta, for extra security measures. One particular cool feature of Okta that I really like is their adaptive multi-factor authentication. They can intelligently allow or block certain connections based on suspicious activity. So as a quick example, if one of your users suddenly logs in from Russia an hour after logging out from Texas, the system will simply deny that access, block the Russian IP, and notify our admin staff without any sort of intervention on our part. So let's take a look at what this guy looks like. Here is an example of a site detail page. You'll notice a site list on the left, which features filtering options. On the right, you can see that we have 2 charge pumps, 2 injection skids, and a few tanks along the top, each having their own card to display its data. We use color pretty extensively to convey information, borrowing only a few ideas from the high-performance HMI crowd. Clicking the header of any of these cards or the right chevron will open that equipment's details view, which you can see here on the left. The options with the pencil on the right-hand side are editable by the user. Certain types of equipment may have control components here as well, such as start or stop buttons, LEDs to show statuses, set point input fields, things like that. Any tag in our system is colored with the typical blue text of a link in your browser to let you know that it's clickable. Once you do, you'll see the details of that particular tag as shown on the right. We simply call this tag details. As you can see, there are several options for interacting with the tag, including a quick trend, current alarm information and history, and extended tag configuration metadata. You can also easily configure new ignition alarms right here from inside of Perspective. These are screenshots of the same site details page on a mobile device, in particular, my iPhone 14. As you can see, things are a bit less graphical. This helps with loading performance when data coverage may be spotty and also makes things easier to see at a glance. Our mobile version has all the features I just mentioned in the desktop version, such as the ability to show detail docs, tag information, edit tags, perform control operations, and anything our security system may allow you to do. It can be difficult to quantify all of the results of such an ambitious project such as this, but here are a couple of highlights. We improved communication throughout Stonehill by arming every level of the organization with the real-time data they needed to make data-driven decisions instead of using pure intuition. The modular design increased operational agility, giving us the ability to execute new initiatives or fix things in a fraction of the time. We're now able to build entirely new facilities by mixing and matching constituent data packages. As an example, I actually timed myself building a brand new saltwater disposal facility. From the time that the tags were published to our broker, the site was being displayed in perspective with users able to make control changes in less than 15 minutes. And that is no exaggeration. I literally timed it. Numerous forms of cost savings here, from decreased windshield time, less time needed on site for repairs or work, and less manpower needed to build and commission new sites in Toscada. Our new associative data model made creating analytics and reports much easier than before. We actually used some of this cost savings to deploy Opto 22 energy monitoring units on our drives and motors. We're, we're actually preemptively collecting the metrics needed for pump health and maintenance predictive analytics. Last but certainly not least, we've proven that our system can scale alongside Stonehill's needs, further cementing a solid return on investment for their organization.